NFPA 72005 Article 210.11 current discusses branch circuits specifically supplying only permanently connected lighting fixtures. Exception No. 4 within this article provides an allowance. It permits the grouping of these lighting fixtures on the same circuit in bathrooms and kitchens. Applying this exception to your specific scenarios, the answer is yes. The bathroom lighting can indeed share the same arc fault circuit interrupter, often referred to as AFCI, circuit as the luminaries located in the bedrooms. Similarly, the kitchen luminary is permitted to share an AFCI circuit with the luminaries in an adjoining hallway. It's important to emphasize the condition that the branch circuits in question must exclusively supply permanently connected lighting fixtures. This means no other types of electrical devices or outlets should be connected to these circuits. The exception is specifically tailored to lighting fixtures that are permanently installed. Now, to elaborate further on the implications and nuances of this code provision, let's delve into a more detailed explanation. This allowance is primarily intended to offer flexibility in the design and installation of residential electrical systems while simultaneously ensuring safety. By allowing luminaries in specific areas like bathrooms, kitchens, and hallways to share AFCI circuits, it simplifies the wiring process and potentially reduces the number of branch circuits required in a home. This can lead to cost savings and a more efficient use of panel space. However, it's crucial to strictly adhere to the condition that these circuits exclusively serve permanently connected lighting fixtures. Mixing lighting fixtures with other types of loads, such as receptacles for appliances or electronic devices, would violate this exception and potentially compromise the safety of the electrical system. One might wonder about the rationale behind this specific exception. The reasoning lies in the characteristics of lighting circuits and the nature of potential electrical faults. Lighting circuits typically have a lower risk of arc faults compared to circuits serving receptacles. Receptacles are more prone to arc faults due to the frequent plugging and unplugging of cords, which can cause wear and tear on the connections. Additionally, appliances connected to receptacles often have motors or other components that can generate transient voltage surges, increasing the risk of arc faults. By isolating lighting circuits from these potential sources of arc faults, the overall risk of electrical fires is reduced. The AFCI protection ensures that any arc faults that do occur in the lighting circuits are quickly detected and interrupted, further enhancing safety. It is also critical to understand what constitutes a permanently connected lighting fixture. This generally refers to lighting fixtures that are hardwired into the electrical system and are not easily removable or portable. Examples of permanently connected lighting fixtures include recessed lighting, ceiling-mounted fixtures, and wall-mounted sconces. These fixtures are typically installed with a direct electrical connection and are not intended to be frequently moved or unplugged. In contrast, portable lamps or plug-in lighting fixtures are not considered permanently connected and should not be connected to the same AFCI circuits as the permanently connected fixtures. When designing or modifying electrical systems, it is always recommended to consult with a qualified electrician to ensure compliance with all applicable codes and regulations. Electrical codes can be complex and vary depending on the jurisdiction, so it's important to have a thorough understanding of the requirements before undertaking any electrical work. A qualified electrician can provide guidance on the proper wiring methods, circuit protection, and grounding techniques to ensure a safe and reliable electrical system. Furthermore, it's worth noting that the NEC is updated every 3 years, so it's essential to stay informed about the latest revisions and amendments. The NEC is a comprehensive set of standards that covers a wide range of electrical topics, and it's important to consult the most current edition to ensure compliance. Changes and updates to the code are often made to reflect new technologies, address emerging safety concerns, and improve the overall performance of electrical systems. In addition to the specific exception discussed in Article 210.11 current, there are other relevant sections of the NEC that may apply to lighting circuits. For example, Article 210.12 covers arc fault circuit interrupter protection, and it provides detailed requirements for AFCI protection in various areas of a dwelling. Article 210.23 covers permissible loads for branch circuits, and it specifies the types of loads that can be connected to different sizes of circuits. Article 314 covers outlet boxes, conduit bodies, and fittings, and it provides requirements for the installation and support of these components. All of these articles work together to ensure the safe and reliable operation of electrical systems. Furthermore, it's crucial to consider the voltage drop in lighting circuits, especially in long runs. Voltage drop occurs when the voltage at the end of a circuit is lower than the voltage at the source due to the resistance of the wires. Excessive voltage drop can cause lights to dim, appliances to malfunction, and motors to overheat. The NEC provides guidelines for minimizing voltage drop, and it's important to follow these guidelines to ensure proper performance of the electrical system. Wire size is a critical factor in minimizing voltage drop. Larger wires have lower resistance, so they can carry more current with less voltage drop. The NEC provides tables that specify the minimum wire size for different circuit capacities and lengths. It's important to select the appropriate wire size based on the anticipated load and the length of the circuit. In addition to wire size, the type of wiring method can also affect voltage drop. For example, using conduit instead of cable can reduce voltage drop, as conduit provides better heat dissipation and allows for the use of larger conductors. Proper grounding is another essential aspect of electrical safety. Grounding provides a low impedance path for fault current to flow back to the source, allowing the circuit breaker or fuse to trip and to energize the circuit. The NEC provides detailed requirements for grounding, and it's important to follow these requirements to ensure a safe and effective grounding system. Grounding electrodes, such as ground rods or metal water pipes, should be properly installed and connected to the electrical system. Grounding conductors should be properly sized and routed to provide a reliable grounding path. Bonding is another important concept related to grounding. Bonding involves connecting all metal parts of the electrical system together to create a common ground potential. This helps to minimize the risk of electric shock by ensuring that all metal parts are at the same voltage. Bonding conductors should be properly sized and connected to all metal parts, such as equipment enclosures, conduit, and metal water pipes. Surge protection is another important consideration for electrical systems, especially in areas prone to lightning strikes or power surges. Surge protection devices, often referred to as SPD, are designed to protect electrical equipment from damage caused by voltage surges. SPD are typically installed at the service entrance and at branch circuit panels to provide comprehensive surge protection. SPD work by diverting excess voltage to ground, preventing it from reaching sensitive electronic equipment. Lighting control systems are becoming increasingly popular in homes and businesses. These systems allow for dimming, switching, and scheduling of lighting circuits, providing greater control over energy consumption and ambience. Lighting control systems can be simple, such as a dimmer switch, or complex, such as a network system with multiple control points. When installing lighting control systems, it's important to follow the manufacturer's instructions and to ensure that the system is compatible with the existing electrical system. Energy-efficient lighting is another important consideration for electrical systems. LED lighting is becoming increasingly popular due to its high efficiency, long lifespan, and low heat output. LED lights consume significantly less energy than traditional incandescent or fluorescent lights, and they can last for many years. When selecting LED lighting, it's important to consider the light output, color temperature, and color rendering index. Light output is measured in lumens, and it indicates the brightness of the light. Color temperature is measured in Kelvin, and it indicates the warmth or coolness of the light. Color rendering index, often referred to as CRI, measures the accuracy of color rendering. In conclusion, understanding and adhering to the NEC is crucial for ensuring the safety and reliability of electrical systems. The specific exception in Article 210.11 allows for the sharing of AFCI circuits for permanently connected lighting fixtures in bathrooms, kitchens, and hallways, but it's important to comply with all the conditions and requirements outlined in the code. Consulting with a qualified electrician is always recommended to ensure proper installation and compliance with all applicable codes and regulations. By following these guidelines, you can create a safe and efficient electrical system for your home or business. Remember that electrical work can be dangerous, and it's always best to leave it to the professionals if you're not comfortable working with electricity. A qualified electrician has the knowledge, skills, and experience to perform electrical work safely and correctly. Moreover, let's address some common misconceptions about AFCI protection. One common misconception is that AFCIs are only required in bedrooms. While AFCIs are indeed required in bedrooms to protect against arc faults that could ignite bedding or other flammable materials, they are also required in other areas of the home, such as family rooms, living rooms, dining rooms, and hallways. The NEC specifies the areas where AFCI protection is required, and it's important to comply with these requirements to ensure comprehensive arc fault protection. Another common misconception is that AFCIs are the same as ground fault circuit interrupters, often referred to as GFCIs. While both AFCIs and GFCIs are designed to protect against electrical hazards, they work in different ways. AFCIs detect arc faults, which are dangerous electrical arcs that can cause fires. GFCIs detect ground faults, which are leakage currents that can cause electric shock. GFCIs are typically required in wet locations such as bathrooms, kitchens, and outdoor areas to protect against electric shock hazards. AFCIs and GFCIs serve different purposes and provide different types of protection. It's also important to understand the different types of AFCIs available. There are branch/feeder AFCIs, which protect the entire branch circuit, and there are outlet branch circuit AFCIs, which protect only the portion of the branch circuit downstream from the AFCI device. Branch/feeder AFCIs are typically installed in the electrical panel, while outlet branch circuit AFCIs are installed at the first outlet on the branch circuit. The NEC specifies the type of AFCI protection required for different applications. Furthermore, it's important to test AFCIs regularly to ensure that they are functioning properly. AFCIs have a test button that can be used to simulate an arc fault and verify that the device trips. The manufacturer's instructions should be followed for testing AFCIs. If an AFCI fails to trip when tested, it should be replaced immediately. In addition to AFCIs, surge protection devices are also an important part of a comprehensive electrical safety strategy. Surge protection devices protect electrical equipment from damage caused by voltage surges, which can be caused by lightning strikes, power outages, or other electrical disturbances. Surge protection devices are typically installed at the service entrance and at branch circuit panels to provide comprehensive surge protection. When selecting surge protection devices, it's important to consider the surge current rating, the voltage protection rating, and the number of modes of protection. The surge current rating indicates the amount of surge current that the device can handle. The voltage protection rating indicates the maximum voltage that the device will allow to pass through to the protected equipment. The number of modes of protection indicates the number of different types of surges that the device can protect against. Proper wiring practices are also essential for electrical safety. Wires should be properly sized, insulated, and connected to prevent electrical hazards. Wire connections should be tight and secure to prevent loose connections, which can cause overheating and fires. Wires should be protected from physical damage by using conduit or other protective measures. Electrical boxes should be properly installed and grounded. Overcrowding of electrical boxes should be avoided. Electrical tape should be used to insulate wire connections. When working with electricity, it's important to follow all safety precautions. Always turn off the power to the circuit before working on it. Use insulated tools. Wear safety glasses. Avoid working in wet conditions. If you're not comfortable working with electricity, hire a qualified electrician. Electrical work can be dangerous, and it's always best to leave it to the professionals if you're not sure what you're doing. Maintaining electrical safety is an ongoing process. Electrical systems should be inspected regularly to identify and correct any potential hazards. Outdated or damaged electrical equipment should be replaced. Electrical codes and standards should be followed. By taking these steps, you can help to ensure the safety and reliability of your electrical system. Furthermore, The specific interpretation of electrical codes can sometimes vary depending on the local jurisdiction. It is important to consult with local electrical inspectors or authorities to ensure compliance with the specific requirements in your area. Local amendments or interpretations of the NEC may exist, and it is essential to be aware of these variations. In addition to the NEC, other standards and regulations may also apply to electrical installations. For example, Underwriters Laboratories, often referred to as UL, standards are often referenced in the NEC, and they provide detailed requirements for the safety and performance of electrical products. Compliance with UL standards is often required by local jurisdictions. Moreover, specific requirements may apply to electrical installations in hazardous locations, such as areas where flammable gases or vapors are present. The NEC provides detailed requirements for electrical equipment and wiring in hazardous locations, and it is essential to comply with these requirements to prevent explosions and fires. Proper training and certification are essential for individuals working with electricity. Electricians should be properly trained and certified to ensure that they have the knowledge, skills, and experience to perform electrical work safely and correctly. Apprenticeship programs are a common way to gain the necessary training and experience. Continuing education is also important to stay up to date on the latest electrical codes and standards. In addition to technical knowledge, electricians should also possess strong problem-solving skills and attention to detail. Electrical work often involves troubleshooting complex problems and ensuring that all connections are made correctly. A meticulous approach is essential to prevent errors that could lead to electrical hazards. Furthermore, electricians should be able to communicate effectively with clients and other professionals. Clear communication is essential for understanding project requirements, coordinating with other trades, and explaining electrical issues to clients. A professional demeanor and a commitment to customer satisfaction are also important attributes for electricians. The field of electrical technology is constantly evolving, with new products and technologies being introduced regularly. It is important for electricians to stay informed about these advancements to provide the best possible service to their clients. Trade shows, industry publications, and online resources are valuable sources of information for staying up to date on the latest electrical technologies. In summary, electrical safety is a multifaceted issue that requires a comprehensive approach. By understanding and adhering to the NEC, following proper wiring practices, using appropriate safety equipment, and staying informed about the latest technologies, you can help to ensure the safety and reliability of electrical systems. Electrical work should always be performed by qualified professionals who have the knowledge, skills, and experience to do the job safely and correctly.